Run to completion, or RTC, is an implementation parameter available with a subprotocol component. RTC is often used when dealing with subsets of data independently of one another. This is because it allows you to run a complete subprotocol for either each data record passed to the subprotocol or for each category of data records passed to the subprotocol. There are 3 options on the RTC implementation parameter. False, the default value, causes the subprotocol to run as it would if the components were not in a subprotocol, meaning once for all data records. Choosing true for each data record causes a subprotocol to behave like a protocol within a protocol. All the components in the subprotocol are executed for each data record passed into the subprotocol. The true for each category option has the subprotocol sort the incoming data records based on the property values specified by the categorize using parameter, and executes all components in the subprotocol once for each group of data records. Let's view some examples to get a better understanding of the utility of this core pipeline pilot function. As mentioned, when RTC is selected, the subprotocol is executed completely for each data record or category of data records. If a subprotocol is not using RTC, as in this example, the behavior of the data records is the same as before the collapse. In this case, we see that a single maximum common substructure is being created for all the molecules, regardless of the cluster to which they belong. Running the protocol will show this in the output. Now we'll see what happens if we uncollapse the subprotocol using the generate maximal common substructure on its own and then run the protocol. The results are the same in the output. This is also seen on the protocol. Here's the protocol with the generate maximal common substructure collapsed into a subprotocol again. Now let's change this to an RTC subprotocol and then run it to see the results. Now we obtain an MCSS for each of the clusters. You can also see that the number of clusters has updated on the protocol. We can see the power of RTC subprotocols by looking at a common task in Pipeline Pilot, saving groups of data records to separate files. This example will show how domain sequences belonging to the same protein can be saved to the same FASTA file. Let's review what the ordinary flow of the sequence data through the components in our example protocol looks like. First, all sequences, domains A and B, are read. Next, pilot script is used to determine the file name based on accession number, which is assigned to the global for each sequence. When all of the sequences arrive, they are written to one file. The output is one file with the name of the first sequence. Collapsing the last 2 components in this protocol to a non-RTC subprotocol would give the same results. If we change the implementation of the subprotocol to true for each data record, it would produce output for each data record individually. Instead, we'll change the implementation of the subprotocol to true for each category and define the categorize using parameter as the property accession number. The RTC subprotocol processes the sequences with the same accession number separately, generating a separate FASTA file for each domain pair. Here's how it works. All sequences, domains A and B, are read. Two different domains enter the subprotocol, and a file name, based on a common accession number, is assigned to the global. When both sequences arrive, they are written to one file. The output is multiple files, each with the name of the corresponding sequence.